Okay, testing. Oh, I hear that. Okay, good, thank you. Good evening and welcome everyone to the President's Lecture Series. And I know this might be a little late, but Happy New Year. Okay, we're still in January. Tonight, we are thrilled and honored to hear from Craig McLean. Craig served in NOAA, which is known as the National Oceanic and Atmospheric Administration, for over 40 years as a uniformed commissioned officer and as senior executive service member. In uniform, Craig retired as captain, operated and commanded research ships of the NOAA fleet, participated in several deep-sea dives in submersibles to explore the Titanic wreckage, and served as the first director of the NOAA Ocean Exploration Program. He served in NOAA's fleet and as general counsel. He also served in the National Marine Fisheries Service, National Ocean Service, Oceans and Atmospheric Research, and NOAA Corps headquarters in operational, legal, and policy positions. Upon retirement, Craig was hired as the civilian deputy assistant administrator and later assistant administrator of NOAA for research. There, he transformed the research arm of NOAA into a mission-focused science service. For 11 years, he was the head of the U.S. delegation to the UN's Intergovernmental Oceanographic Commission, known as IOC. He was a leader in creating the UN Decade of Ocean Science for Sustainable Development, also in expanding ocean measurement and observation systems, and pushed the IOC to support ocean mapping, a very, very important initiative. He also was involved in what is known as today's Seabed 2030 project to map the world's oceans. Craig also served as acting chief scientist of NOAA for 5 years. Upon his retirement in April of 2022, he was recognized by members of the House, the Senate, and President Biden for his dedication to scientific integrity. In retirement, he contributes as an ocean advocate, advising government, academia, and philanthropy. McLean holds a BA in zoology from Rutgers College and a JD magna cum laude from Quinnipiac University School of Law. Craig has been or on the water since he was 2 weeks old. This is a remarkable claim to fame. Also diving for over 52 years, and he is known in the DC area as a pretty tight backbeat blues drummer. So Craig, I don't know exactly what that means, but it really sounds fabulous. Okay. I hope you'll join us after this incredible lecture for a reception in the rotunda of the Byrd Center. But right now, please welcome Craig McLean. Thank you.
Good evening. Maybe I should start with an explanation of what backbeat drumming is. Well, if you're coming across to an audience when you're playing music as a performer, folks generally look at you pretty still-faced. But if they're tapping their feet, you're getting across to them. You're really providing something that you could see the people are resonating with the music. But when they start swinging their hips, there's a deeper pocket in the music, there's a deeper groove, and that's when backbeat really comes in, and now you know you're coming across. Any musicians here tonight or remotely, you'll know what I'm talking about, but I'd like to think it's time acquired. Well, it's delightful for me to be here tonight, and thank you, President Hendricks, for the invitation. I also want to recognize Rear Admiral Bill Stubblefield and his wife Bonnie, the creators of the Stubblefield Institute. I think there's no higher order of what we deserve as a society to have than civil discourse on complex subjects. And doing it with grace, with dignity, objectivity, and recognizing the importance of views that may be different than our own, and having an opportunity to learn what other folks might feel and how that might influence the way we feel, and vice versa. And where we really get into trouble is where we put walls up and we isolate ourselves and we just listen to those components that are more comfortable to us because it's what we think we will continue to believe in. But every one of us grows over time. Every one of us changes over time. And I think the Stubblefield Institute and Shepherd University are a wonderful combination to be able to advance that. So thank you for inviting me here tonight. I plan to talk about oceans, the politics of oceans, and when I say the possibilities, I'm going to try and end on a very positive note that you might take with you and share with other people. I'm also going to invite you, for reasons that will become apparent shortly, to take some of the snacks that I've brought here for you. But I have to warn you that, seriously, there are peanuts in these, and our granddaughter, my lovely wife Joanne joining me here today, our granddaughter has a peanut allergy, so do many kids, many people, so just please be careful. But there's nothing like Cracker Jack. You probably grew up with it. But the story to be told here, so. Well, thank you very much. So coming to West Virginia, and I've been the guest of the Stubblefields here for a number of wonderful occasions, and their hospitality is rich and warm. I've also been a guest of Shepherd University past, with President Hendricks inviting me here, and I'm thrilled with this university. But looking at West Virginia, my exposure to West Virginia as a NOAA ocean guy was that we have a computer center that's in the side of a mountain on the way out of here. It's an interesting facility. It's secure being here in West Virginia. It's away from most of the severe weather onslaughts that we might expect to be confronting. But it was a momentous time for me because I was the practitioner of consuming up to 18 plus cups of coffee in a day. And I was driving back from this West Virginia computer facility. And anybody here remember Inagata Davida? Oh yeah, here we go. We've got an active group here. So Iron Butterfly, Inagata Davida, 18 minutes, 12 seconds, drum solo. My heart started doing that as I was driving back, and I suddenly realized that it must be the caffeine. So as I'm driving, I thought, what should I do? Should I pull over and write a note? Should I call Joanne, tell her I love her? Oh, wait a minute, there's a hot dog place over there. So I got off and got a hot dog and a Diet Coke, which actually has caffeine in it, so I didn't do myself much for it. I did switch to decaf, but that's part of the story coming up next. And I will now advance to really a key question here for us tonight. So how relevant is the ocean to West Virginia? So what do? You go and talk to AI. AI will solve everything for us, won't it? So please note, AI tells us that West Virginia is a landlocked state, so no one from West Virginia goes to the Atlantic Ocean. Thank you for coming tonight. I'll conclude my remarks with that. And so obviously AI is not the solution to everything. We have a ways to go with that. But let's look at why the oceans are relevant to West Virginia. And I'm going to draw your attention to the Indian Ocean. And that's an area that maybe some of you have visited. I know that my former admiral and boss has been there many times. It's an interesting body of water. But what's more interesting about the Indian Ocean is if you look at the rest of the map, and please use your imagination here with me, there's a landmass that goes from nearly pole to pole. And it's one of the few places, if not the only place on the globe, that there's a disruptive landmass that goes from the North Pole just about all the way to the South Pole, except for the Southern Ocean down here. That makes the Indian Ocean and what happens in the Indian Ocean remarkably relevant to the rest of the world and how the weather goes from the west to the east and starts to bring weather patterns in a development that only after World War II did we begin to understand. Up to that point, weather was, gosh, if we want to know what's happening in West Virginia, let's find out how the folk in Kansas are doing, and let's see what we're going to get tomorrow. But by monitoring these areas of the ocean and the Pacific and the Atlantic, the Arctic, the Antarctic, by starting to monitor the ocean, we wound up in the year roughly 2006 of finding models for weather that could extend into a weather extended outlook, a seasonal outlook. And folks, weather times time equals climate, so we can start calling them then climate outlooks for what the weather prevailing will be in time. But it all starts with monitoring the ocean in areas that started with elucidating or revealing what was going on in the Indian Ocean. So for West Virginia, we care a lot about what's happening in other oceans and other parts of the world. The entire agricultural belt of the United States looks at these seasonal forecasts. In fact, these seasonal forecasts were even investigated by the Securities and Exchange Commission, the SEC, because people were buying and trading futures based on these scientific forecasts. And the concern was, when do you release these forecasts? Because they clearly are influencing the market. And if they're influencing the market, they're influencing the finance industry as well. So very much science has been translated into informed economic investments at many levels in many industries: the transportation industry, the agriculture industry, the insurance industry. So science has really driven a lot. And though you may not have the ocean lapping at your coasts, you are influenced by what's happening in the oceans of the world, because those are the weather makers, the weather generators. So I would go back to the AI folk and let them know that they've got at least one error. The people of West Virginia do find the oceans relevant. And I do believe more than none of you go to the coast in order to enjoy the recreation opportunities there. All right, since this is a talk about the ocean, I got to show you a picture like this just to keep you attached to what's up on the screen. Any photographers here? Very good, very good. This shot was made, obviously black and white. I would shoot, this is in the days of film, not video, and I would shoot rolls of 36, as I'm sure many of you did. I shot several rolls of Kodachrome, but you can see it's a gray day, so it's not too stark with Kodachrome, which is a vibrant expression of color. But I shot then black and white. I was on a Bogan tripod that could support my own body weight. I was shooting a 400 millimeter lens, and that's pure suicide in the kind of ocean that we're in at the time. But I had 3 crew members, one holding me by the belt and the back of my neck, one on each side of me, and then actually 4 crew members, because one fellow was weighing down the tripod as I would just wait for that moment when the ship slid into the view. It's part of what excited me at that point in my life, at that point in my career, was being at sea and seeing the full fury of the ocean, but also the great peace and the calm of the ocean, and really learning what's under it, what's in it, what is around us but the ocean, and how it relates to our lives daily. So with a little bit of seafaring, and that is the proud NOAA ship Delaware II. It's now retired. The ship that I was on at the time was the Albatross IV. It as well is retired. Those were ships that sailed out of Woods Hole, Massachusetts. But one of my favorite shots, and I actually saw a painting that a chap had done of this photo. And when I asked him where he got the photo from, he said it was on the internet. It's like, oh, all right, I'm getting exposed, I'm getting out there. But, all right, so the oceans matter how and why. So here are some subjects for you to consider. Seafood eaters, we have to manage the balance of consumption with replenishment and replacement of seafood stocks. But the world relies on seafood across many oceans. In terms of climate moderation, the ocean is a great insulator. It absorbs so much more heat than the landmass does. If the ocean wasn't absorbing the heat that we are receiving from the sun, our temperature would be much, much higher. So the ocean is a wonderful buffer, a wonderful insulator of the heat that the Earth acquires. Biodiversity gives us the enjoyment of many species that add to our quality of life, one which I'll show you shortly that actually guarantees our life, not quality of life, but our life. I mentioned Weathermaker. It is an oxygen generator through photosynthesis, but recently folks have found that manganese nodules, these small geoids that are on the bottom of the ocean, are actually producing oxygen without sunlight. And that's new chemistry. And I don't think science today knows exactly how that works, which is what science is all about. You find new things, and you try to study them and elucidate what's happening there. So a number of expeditions are being mounted now out to the Clarion-Clipperton zone to pick up some of these nodules, but more establish monitoring sites to figure out how much oxygen is being produced, but more importantly, by what mechanism. Because once that mechanism may be understood, it can explain where and how life may exist on other planets. And that's pretty important. I will guarantee you that that'll get a lot of money looking for life on other planets. We still haven't fully defined the life on our own planet yet. So that's why this discovery, I think, was so important. Pharmacology. Since I'm comparing space with oceans, can anyone name the number of drugs that have been developed because of space exploration? You're a very attentive audience because there are none. But if I were to tell you the dozens that have come from the ocean, and the reason that they're effective and why the ocean is a source of pharmacological study is because those components of marine life that preceded us in our evolution, they have the same chemical pathways, they have the same cellular components and pathways as we humans do. So it's very important to understand those mechanisms because we have them in us too. And we could find something much more simple to explore and discover in some of these creatures in the sea, because that is our phylogenetic record. That is how we have evolved over time. So the pharmacology that's come from the ocean is something that is very important, and that tracks back to biodiversity. If we wipe out species unintentionally by our activity and our conduct, we're missing the opportunities to find those additional pathways, and most of them have dealt with what I'll call intercellular conflict, basically cancer. They are remarkable in what has been discovered. Okay, coastal community protection and prediction. The largest investment of private money in the United States of America is on the coast, privately held by landowners. It's joyous to live very close to the sea and have a beautiful vista out the back windows, but at the same token, there's remarkable vulnerability there. So how as a society can we handle and adopt to the changes that we're seeing with more ferocious hurricanes? Not more frequent hurricanes, that's not yet statistically sound, but certainly more ferocious, more water-bearing, windier, faster to accelerate and intensify. That is what is happening now. But yet we have so much property invested by private hands that is increasingly vulnerable, and you're going to be feeling it, as will those coastal residents, in their insurance rates. But is it fair? It's a reality, but is it fair that in the mountain you might find, or in the hills you might find, insurance rates going up in order to pay for what's happened at the coast? That's a reality that we're in. The geopolitical influence. Okay, here's the first ridiculously pronounced acronym that hopefully is the last one I'll mention tonight, but the UN Convention on the Law of the Sea. I'll mention later the general lawlessness of the ocean, but that's confounded and compounded by a treaty that was produced in around 1982, the Convention on the Law of the Sea. This is the international agreement that describes how nations treat each other. It's not a simple document. It's quite complex. It deals with the jurisdictions, it deals with the conduct between governments, it deals with seabed resources, fishery resources, just about anything that you can think of under the law that nations are abiding by or have been abiding by. A thick document, worthy of extensive study, but miraculously the United States is not a member of this treaty. And if I were to list for you the countries that aren't either, you would not be favorably impressed. Civilized maritime nations except the United States are members, and very well-developed democracies are all members. The United States isn't. It was a political issue, and it still continues to be a political issue in the mindset of one party not wanting to join anything that is UN-oriented, and another. This has been going on for years. This is not recent. This has been going on since Ronald Reagan's presidency. So the fact that we're not a member puts the United States at a significant disadvantage, because decisions are being made in the international community that we are only a spectator to. Whereas every other aspect that deals with the ocean, the United States in science is the leader. If the United States doesn't do it, other nations don't follow. If we do, they follow. And I've seen that for 11 years in my work in that UN body, the Intergovernmental Oceanographic Commission. Okay, so that's the UN Convention. This BBNJ, sorry, I didn't try to pronounce that. Anybody got an idea how we would pronounce that if we were to try and make it? No, let's let that go. We'll just leave it as BBNJ. That's biodiversity beyond national jurisdiction. It goes back to that treaty. Every nation is responsible for protecting our own resources, which would be our 200-mile exclusive economic zone. But who's going to protect the commons? Going back to the old English villages where we had the commons, where everyone would graze their sheep or their livestock, and no one took care of it because it was for everyone to take, and no one protected it. So it was typically over-harvested and damaged. Well, the oceans, the blue ocean, is a commons. And this treaty, nested underneath the Law of the Sea Treaty, would look to define how we're going to protect the global ocean. Now this one, this is a cute one, this 9-dash line, I'm going to show you that on a chart, but this is China's interpretation, which boldly departs. China's a member of the Law of the Sea Treaty, but it boldly departs from what's here. And China has defined their own Law of the Sea anew, and they're the only ones that believe in the aspects that they're bringing forward, and it's producing quite a bit of trouble for the international community to be dealing with a major maritime power that China is when they're making their own rules. More on this to come. Okay, so now let's talk about some information. John Kennedy, charismatic young president, World War II Navy veteran, PT boat skipper, a hero once that PT boat was crashed into by a Japanese destroyer. But Kennedy offered this quote, and I draw your attention to that, which is highlighted. Same percentage of the salt in our blood as exists in the sea. I love that. It's romantic. It's inspiring. It's wrong. The oceans have 3.4 to 3.6% salinity or percent of salt in the water. Our blood, every kid has tasted the blood of a nick and a cut, and it tastes salty. There are many other ions in our blood that give us that taste reaction, but it's only about 0.8% salt. So it's about 4 times, the ocean's about 4 times saltier. But it sounds good. But I point this out to just ask you to be mindful of what is the authority that you're choosing to listen to about the subject. Should the president be my educator in oceanography? Or should I be looking for more authoritative sources in order to be rendering an understanding? But I have to give it to Kennedy. With his charisma, with his youth, he brought the country during an age of television which made many realities available to the public that had not been before accessible. And it was really his vision and energy that brought the space program forward, and also inspired some oceanographic investments as well. Lyndon Johnson after him. All right, so be careful who you trust. So with that in mind, that is me. And how many people have driven over Route 95 between maybe DC and Philly, and you've gone over the Delaware Bay Bridge? All right, a couple of travelers here. Next time you go over that bridge, remember that it's safe, secure, and sound because I inspected it. But I ask you to look at the visibility of that water. This is not a vacation. Would you trust this guy to tell you anything about the oceans? I'll leave that there. But I'm proud of my beginnings, which were zero visibility diving in many bodies of water that I'm sure you've been near or on or hopefully not under. But that was in my college days. Handsome devil, isn't he? He just, that was in my college and 1 year out of college before I joined the service and then embarked upon a career on ships. Not for the faint of heart. That was some nasty stuff. Can't see anything. It's absolute black. The first 18 or 24 inches is like cream in your coffee. It's basically that color. You could detect light, but going another foot deeper, it was zero visibility. So for those fellows that dove under the bridge in Baltimore to remove those parts and pieces, I have great respect for what they did and how they did it. But I decided it was time to change careers just after enough hours underwater in that environment and realizing literally how dangerous it would be. So I was a wimp. I got out of it. All right, so here's something. How much water is on the Earth? Is that believable? Yes, it is. It's well calculated by the U.S. Geological Survey and also the Woods Hole Oceanographic Institution. That blue ball right here is the amount of water that's spread throughout the rest of the globe. Another analog of that would be, as disbelieving as that sounds, another analog of that would be if you had a tub of water and you put a basketball or a soccer ball in it and immediately pulled it out and looked at how much water was residual on that ball before it all dripped off. That's basically what the world's oceans are. To us, it's staggering. The Mariana Trench is 36,000 feet deep. That's 6+ miles. So when you're flying over the country and you look out at 6 mile high elevation in your plane, imagine that is how deep the ocean is at that one location. Deep ocean is only about 2% of the ocean. The rest of the ocean is a much more moderate depth. Still deep for us because you can't stand there. But when you take that water and smooth it out over the ocean, it is a finite quantum of water. It is therefore easy for me to understand how our human population, as large as we are but growing, probably leveling off between 11 and 13 billion according to the UN, that'll be our carrying capacity on Earth. But if we look at that, it is at least understandable for me to say this quantity of humans on this planet are influencing that body of water. It's not as immense as we see it when we stand at the edge of the sea and we look out towards Europe or anywhere else. Similarly, if we look at the atmosphere, 60 miles thick, 60 statute miles thick, or 100 kilometers. It's a very thin envelope of atmosphere that's in and around this planet. Once again, when I look at the population that we have, it is not beyond my ability to comprehend that we have influenced that with the products of our progressive society and the conveniences that we have enjoyed since the industrial age. It is not that thick, and we have caused an influence on that. I grew up on a river in New Jersey. It's called the Passaic River. You notice the way I pronounced it. It's properly pronounced the Passaic, but when you come from New Jersey, you got to put your shoulder into it and you say it's the Passaic River. You've seen The Sopranos. Okay. That river was one of the 10 most polluted rivers in the country, and it was in my backyard, literally. I couldn't swim in it. We would boat on it, but we couldn't swim in it. And it was such a disappointment to realize what it could have been or what it was 1 or 2 generations before my time. My dad swam in that river. Whether it was advised or not, it was much cleaner, and he swam in that river when he was a kid, but I couldn't. That brings me to this and the notion of what influence we've had on the ocean ourselves. So it's something for us to be mindful of. The conveniences of our lifestyle has brought great benefit, great comfort. It's allowed us to define the conveniences that we have and we've passed on to our kids and our grandkids. But what else are we passing on to our kids and our grandkids? I want you to please think about that. All right. Just about every high school or college biology book has this in it. Should be quite familiar to you. That's photosynthesis. Absorb carbon dioxide by green leafy plants and materials, grass, trees, and the like. But how many times have you seen this? You haven't. That's not in your books. We're so terrestrially minded, but more than 50% of the oxygen that we breathe comes from the ocean. More than 50% of the oxygen we breathe comes from the ocean. We don't teach that. We don't hear that. We don't learn that. And if we did, I think we might be a little bit more ocean-minded, whether we live in West Virginia or whether we live on the Delaware shoreline. So it's something to think about. And these microscopic organisms, these planktonic organisms, are photosynthesizing, and they're producing all of that oxygen. Now, as we change the acidity of the ocean, there is an impact on these colloquially, we might call them bugs, the small microorganisms. How we change that or how fast we change that is very concerning because half of our oxygen is coming from the world ocean through these microscopic organisms. All right, I hope you could see this. This is a conveyor belt of ocean heat being transferred. Sir, in the back, is that discernible? Can you? Thank you very much. So what you're seeing in this red line is equatorial heat with ocean currents coming up to the poles. And once again, equatorial heat being transferred to the poles. That's an artifact of a rotating Earth and a series of physical phenomena, one of them called the Coriolis effect, but it's nonetheless laws of physics on a rotating sphere that has water on it. Currents evolve in such a direction. When those currents evolve, they transport, among other things, fish, microbes, but also heat. So the equatorial heat, the equator's hotter because it's a direct angle absorbing energy from the sun, as opposed to a more tangential angle that would be near the poles. As that heat is transferred, it also then goes to the polar regions, and then it cools off, sinks, and comes back down in the bottom of the ocean, and goes all the way back down to Antarctica, and starts again by being warmed and coming back up. It takes about 1,000 years for one molecule of water to make that journey, wherever it starts. And that sounds a little conflicted, but realize that the amount of heat it's absorbing as it's slowly moving is huge. It's a great amount of heat that the ocean absorbs. The fact that this conveyor belt of heat transfer is working is the reason why on this side of the Atlantic, at a high latitude, it's pretty darn cold. Whereas over in Europe, they have a more temperate existence, a more temperate temperature and climate because of that ocean heat. Now, as the Arctic melts, and as the Antarctic is melting, that conveyor belt is of high risk at slowing down, if not stopping. And that would be very disastrous for what we've built over the past 6,000 years of our civilization, because coastal cities have been rather stable in terms of elevation for the 6,000 years that we've really had any advanced level of civilization. So this is a concern for us. This is a physical oceanography concern based on the amount of heat that we are absorbing on the Earth because we are producing heat-trapping gas in that 60-mile thick atmosphere that contains it and holds it and just heats up more. Now, that's not wayward science. That's not way out there that nobody's thought of. The late 1800s, this was discovered by a physicist who realized if you put CO2, carbon dioxide, into a closed atmosphere, which effectively we have, gravity keeps that atmosphere attached to Earth, it's going to warm up. And the more carbon dioxide you put in, the warmer it's going to get. That's a law of physics. That is not disputable. Here's the real application of it, how it's affecting the ocean and the world around us. That ocean feeds us. It feeds many people more than the average American. There are many countries and societies that are eating much more fish per capita than we do. Fish is very healthy for you, something to consider, and it's a very positive element of people's healthful diet. But the balance of the ocean in order to sustain these fish populations globally is concerning because unlike the United States has the fewest number of overfished managed fish stocks of any civilized nation, because for the past 4 decades, the United States has been very focused on reducing and ultimately eliminating overfishing. So our fish stocks are largely healthy. But what's changing about our fish stocks is that they're migrating north. They're going in a polar direction because the water is warming. So today's Connecticut and Rhode Island lobsters, they don't have lobster much anymore. Their fishermen go up to Massachusetts and New Hampshire to collect lobster. And the Maine lobster, which is the stuff of billboards on highways, the Maine lobster are tomorrow going to be Canadian lobsters. So that ecosystem is migrating upward because of the warming ocean. So there are changes around us fully. So we monitor the ocean in order to figure out what's changing, how fast, and this is what Admiral Stubblefield and I and many others have done, and Dane, where's Dane, who have done at NOAA. And that's our job, is to monitor the patient, the pulse, the respiration, the blood pressure, taking the vital signs of the ocean with these oceanic systems. And I also have a little slate over here is Gray's Anatomy. Nice to have a Gray's Anatomy of the patient. May you be surprised to learn that we've only mapped about 26% of the global ocean. Do you remember MH370, the airplane that was lost in the southeastern part of the Indian Ocean? Still a mystery today. The first sophisticated scientific equipment that was brought to play there to go and look for that or bits of that downed aircraft were 2,000 feet shallower than they needed to be in order to get any reasonable reflection off the ocean bottom. Why is that? Because the reconnaissance surveys that were available were so incomplete that there was a general lack of knowledge as to how deep that water truly was. So I went back and I asked a gentleman who's, to me, the world expert in ocean mapping, a gent named Larry Mayer, who's up at the University of New Hampshire. And I asked him, well, let's go to the Atlantic. If that was so unknown, how many places in the Atlantic do we have where we would have a similar challenge in knowing the true depth of those ocean areas? We've fought 2 naval wars in modern time across the Atlantic, World War I, World War II. We've got the Cold War. We have people insanifying the ocean bottom for various reasons. Do we have anything like that in the Atlantic? And he said, oh, of course we do. And he showed me a map where those areas would be as equally poorly understood. So we have a ways to go. But we still know a lot about it, but we can know so much more about it. So as we monitor the ocean, there's a device that we call an Argo float. And the Argo float is about as tall as I am. Unfortunately, I'm not as thin as an Argo float. It's about 8 inches in diameter. It's a columnar device that has a small, I'll call it a buoyancy engine in it with a battery. It expands and contracts a buoyant bladder that lets it sink and then come back to the surface. These Argo floats sample the water in physical parameters, the temperature, the pressure, the salinity, and they go down to 2,000 meters over the course of 10 days. They go down for about a day or so, and they make a traverse wherever the current's going to take them. They come back up in another day, day and a half. So a 10-day cycle. And they do autonomously 365 days a year times usual life of these devices is about 8 years. They do that work diligently. In our earlier days, speaking to a pure oceanographer here, doing that by ship would take about 40 people, a lot of fuel, many days at sea, to stop at any one of these locations. And these are random, by the way, because these are free-floating devices. But we would stop at locations roughly 2 to 3 hours down, 3 to 4 hours back up of a physical sampling device that was on a winch and a wire. So by automating or taking humans out of the equation and having automated material, we're measuring all of this ocean 24 hours a day, every day. Now, the system was originally designed to have 4,000 units. We've never reached 4,000 units. The system was designed in the late 80s, early 90s. And I think I mentioned earlier how in around 2006, all the ocean models, regardless of their modeling architecture or design, they started to agree and gave us those very good climatological forecasts that gave us the seasonal weather. It's because of this system largely. But now, let me show you something here if I can. This is 3,800 of those devices. But I told you that they have a 10-day cycle. So if we look at how many of those devices are around in any 2 days, here's a 2-day snapshot of the ones that are at the surface and able to report their observations back to every weather service in the world. It's far fewer. Now take a look at the continental United States. Obviously, we have no oceanographic sampling in the continental United States. There's no dots there. But look at an equal size to North America, to our Pacific side, and to our Atlantic side. Make it easier for you, there it is. So for our weather forecast in the near term, based on ocean conditions, that's what we would have analogous to the mainland U.S. and that in the Pacific and here in the Atlantic. Now, you want to see how many we have on land to give you your weather forecast? Every blue dot is a certified and calibrated weather observing station. Some of them owned by the National Weather Service, some of them owned by broadcast meteorology firms and companies and stations, and some of them on top of schools. Universities, of course, but also schools. So we flood the landmass for accurate weather forecasts. We have a ways to go on the ocean in order to give you those better forecasts. But that's the distinction between having an ocean-mindedness, and God bless Jack Kennedy, whether the blood thing was right or not, it's something for us to resonate with and remember, that even in West Virginia, we have the result of ocean phenomena taking place and coming to us. All right, so what's the world look like today? These graphs are probably self-explanatory, but you could see that in each of these attributes, we have a change over time, and this is really relatively recent time, at least from the industrial age forward, but even more recent, since World War II forward. So the planet is warming, sea level is rising, glaciers are diminishing. Each of these attributes you can see for yourself. There is change going on, and these are highly calibrated and highly measured phenomenon. So we are changing this world. The world is changing around us, yes. Why is it happening? It's the atmospheric greenhouse gases. How does that work? Well, if you go back 400,000 years, both through a geological record and then also scientific instrumentation that really was just up in here, but looking at the geologic record, which has been really unchallenged, you're watching things here change about the carbon dioxide levels in the atmosphere. I had a chap tell me, what are you so bugged out over the carbon dioxide levels in the atmosphere now? The Earth has had those levels before. Well, yes, but we've not been there. And the world that we've evolved in wasn't like that either. So if you look at this change, if there are many facets, what is the impact of the sun? That's lost in the noise of these curves. What is the impact of the wobble of the Earth in its rotation around the sun, both in the axis, north and south, how it's wobbling, and then also as this geoid. We're not a perfect sphere. We have a little inertia that's off axis. All of those factors that people might cite, they're included in the noise of this to the point where we have a high and a low, a high and a low. And as you look at that, you could see where we are. Anybody know if we just stopped here in time and didn't look at where we are today, where should that curve go? It's going down. Thank you. Thank you. It's going down. So let's look at what that would mean. Here, we've really ramped up in the last century and a half. And here is where, to my friend who said, well, come on, we've had high levels of CO2 before. Well, human evolution, we started way back here, and we haven't had anything like this. And human as we know them today, Homo sapiens, these are our ancestors. These are our very ancient ancestors. But Homo sapiens migrating out of Africa was only 75,000 years ago, and here we are today. So the world we know basically started around here at 6,000 years ago. That's when all the European and all the Asian and all the cities that were built on sea level as we knew it and started international commerce and the like, and human migration. So the world's changing very rapidly around us, and that's concerning. So now what does this tell us? To repeat that previous diagram, you're looking at CO2. So when it comes up, it's warmer, colder, warmer, colder. And the global temperature, colder, warmer, colder, warmer. But look at sea level. Sea level tracks that. Sea level tracks that pretty well. So where are we right now? And as the gentleman and others voiced and said, well, we should be going back down in this cycle, but we're going up. We should be, to look at sea level, we should be going into an ice age. An ice age. Now, it doesn't happen overnight. In geological time, we would be going in towards an ice age. But instead, we're warming the planet to a remarkable degree, and we're at 425 parts per million right now. And that's why I brought you some Cracker Jacks. And remember peanut allergies, please. But everyone's invited to take a Cracker Jack box at the conclusion. When I was a kid, Mom brought back Cracker Jacks, and it was a snack for us in the house. And you remember, it's candy-coated popcorn, peanuts, and prize. You're a plant. My wife knew the answer. She's a plant. But so I ripped open one of these, and the one that stayed with me was that if the polar ice caps melt, this is according to science, according to Cracker Jack, if the polar ice caps melt, sea level could rise by 4 feet around the world. And I thought, oh my goodness, that's amazing. But that's where I left it. But I had no idea that that reality could be upon us. So if you look that our level of CO2 has not been on this earth for 3 million years. And obviously people have not been on this earth for 3 million years. Now remember geological time. This doesn't happen overnight. But nonetheless, where we are, we've not seen this before. So once again, to my friend who tried to diminish my concern because the Earth has enjoyed this type of atmosphere before, but never with us on it. And sea levels were significantly higher. Say goodbye to Florida. There's no Great Lakes any longer. The coastline looks very different. West Virginia is not quite waterfront, but near it, as the intrusion has come in water levels. Now, that's not going to happen overnight. But the problem I would offer to you is that if you did a probability risk assessment of this circumstance, the harms are remarkably great. The odds of it happening are very high. The only question is when, how fast. I don't know if you noticed it, but when I showed you those oceanographic measures and the place of the Argo floats around the globe, there's not much in the Arctic, and there's not much in the Antarctic and on the Southern Ocean. And those are the most rapidly changing areas on the Earth of ocean temperature and changes in their ocean waters. So one of the things that I would draw your attention to is that we don't seem to have a propensity to spend the kind of money that we perhaps should, to be looking at reducing the risk and assessing that probability risk equation as to where we are. And there's also a lot of folks who don't buy this. All right, the sun, we've got that accounted for. The wobble in the earth, we've got that accounted for. The calibration of instruments, the truthfulness of the geo record has been calibrated and shown through a number of things. Ice cores, tree rings, any number of proxies for direct measurements that have been proven in contemporary terms to be legitimate. The only thing is what we're doing to the atmosphere, which is therefore doing to the ocean. So we're not the only ones, federal scientists and academic scientists, who think this. So there was a very good paper in Science, the journal Science, that assessed oil companies, coal companies, and automobile companies, climate scientists, and yes, they employ a high degree of climate scientists. One of the laboratories that I was responsible for had scientists who would come in for years visiting with our climate modelers to perfect their own climate models. This particular lab is in Princeton, New Jersey. It's a combination of NOAA and the Princeton University. So the oil companies have been very much a part of this pooled intellect. And I'll just save you the trouble, but the conclusion from this review was that the industry scientists predicted global warming correctly and skillfully. So this has been known. This is not a bunch of green people with Birkenstocks and Greenpeace membership cards coming up with these ideas. These are people who are sound scientists regardless of who they work for. So I'll go back to one more point I made it earlier. We elect policy. It's a public political choice. We do not elect science. The science stands on its own merit. And the science here has stood through the development of multiple communities in order to prove what we know is a reality today. Because if you look back when these papers were published, and there are many science papers published since the 50s, 60s, 70s, that's the reality we're living today. It's what was forecast back then. We're living it today. More severe storms, severe droughts, severe inundation and deluge of water. It's entirely fitting to what those forecasts were. So where do we go and what do we do about it? Trying to get the international community to agree is very challenging. This map on the left-hand side is provided by, actually, this will sound impressive, but perhaps you know that it's not. The CIA produces this map. Anyone can get wonderful geo-based information from the CIA. They have a wonderful website. Take a peek at it. It tells you a lot about a lot of places. This is what China has declared as their 9-dash line. These are the dashes, 1, 2, 3, 4, 5, 6, 7, 8, 9. This 9-dash line is China's interpretation of what their heritage ownership of this body of water might be. They're finding shipwrecks in that area, never mind the Portuguese shipwrecks that are in there, the Spanish shipwrecks that are in there, but they find a Chinese shipwreck in there and they say, see, these have been our waters since time immemorial. Well, they don't really care about archaeology, and they don't really care about naming, even though their convention is very different here, the Yellow Sea versus the South China Sea. What they care about is this is the throughway for the delivery of energy to China. It comes through the Straits of Malacca, which I'm sorry is off the chart right here down to the left, but they bring in oil and coal and other resources to China through that route. They want to have dominance over that and not be subject to, among other things, the international law of the sea. And I commend you, if you're interested in this subject, to this book that appears on the right here by Isaac Carden. Dr. Carden was studying law in China as a Westerner, and he was in the room when many of these developmental discussions took place. So it's a very insightful book as to what is the thinking behind China's take on changing the international regime of law. And it's concerning because under the Law of the Sea Treaty, you can bring a grievance to an international tribunal. Vietnam has, Philippines have, Taiwan has, and the international tribunal found against China. Well, there's no penalty for failing to listen to the international tribunal. So basically, China will continue in a belligerent way to do what they want to do. There's no seeming penalty for that. All right, so if you could see that picture, you can kind of read the body language here. Not always was it a joyous engagement in trying to negotiate with the Chinese about such matters, whereas many other places that I've had the chance to go and do our nation's work, very different reaction. But the stonewalling is something that I think is worthy of recognition. And it's unfortunate because as a global community, we all need to be working together at some of the problems that we have here. I sound a little too Pollyannish, but I think that's the truth because no one nation can fix these issues that we're dealing with. All right, so another issue. You might have seen in the news that submarine telecommunications cables, and this is an artist's rendition, of course, but submarine cables bring us our internet. They bring us the transition and transactions of finance. They bring us information, whether it's familial greetings or your stock market accounts. It's all going under submarine telecommunication cables. And a very worrying series of events has taken place here. Just about a year and a half ago, started to appear in the intelligence community discussions that were shared with the public, the concern about the vulnerabilities of submarine telecommunication cables. And now we see that concern, which was generally associated with Russia and the Russia-Ukraine war, not that it was going to stop the Ukraine war, but it was a potential Russian move to try and further isolate the surrounding nations around them. But if I can draw your attention to this anchor, there's obviously a piece missing. It should be symmetrical. So this anchor had dragged over a communications cable, broke the cable, but obviously also broke the anchor. I've seen images as well from other sources that have both anchor, both legs of this anchor ground down. And that to me would be an indication that somebody purposefully would lower the anchor to grab a cable but not stop the ship. You're not going as deep into the sediment. So it's an active practice, sponsored by whom is still an open question. But once again, back to the law. It's illegal to mar and manipulate cables, but what do you do about it when somebody does? Those are the problems we have. Worse for us, not being a member of that treaty, we have even less to stand on when we bring these objections. But this is happening with increased frequency. It's happened most recently, just in the past couple of months, out in the Taiwan Strait, and then also in the adjacent to Finland, adjacent to in the Baltic Sea area, for multiple nations being impacted. All right, so here's a little funny one for you. Lettuce plus coffee equals money. So, oh yeah, where's this guy going with this? First of all, we got the Cracker Jacks, now we got lettuce and coffee. All right, so some years ago in NOAA, we were able to start an ocean exploration program. I was very fortunate to be asked to serve as the first director of that program, to get it started, get it off and rolling. So the Congress gave us $4 million to go and explore for that year the world's ocean. So my question to our congressional friends was, what square nautical mile do you want us to look at for $4 million? And they, yeah, okay, McLean, you're funny, but just go do what you can. So I went down to NASA, to a joint NASA and NOAA space and ocean exploration, because I figured, let's go with the pros. These folks have been exploring for decades now. How can we help each other? While there, I was given a tour of a laboratory that grew green leafy plants, lettuce. And that laboratory was for the purpose of providing the astronauts with green leafy material instead of toothpaste grade material that they were routinely using, which is challenging, especially if you're going to go to far distant places well beyond the moon, including Mars. All right, so I asked the gents there, that's really intriguing. You're growing lettuce up on the space shuttle and other places. What's your budget? You want to guess? $4 million. So I go back to the Congress and I say, well, by golly, you've given us the NASA lettuce budget to go and explore the world's oceans. Can't you do any better than that? And they said, all right, McLean, what are you going to do with that $4 million? I said, we're going to do 8 projects this year. So the person who was the counsel for that committee said, McLean, switch to decaf. You're too high charged. You're not going to get 8. So we go away, we have a year's worth of work with the NASA lettuce budget in pocket. I come back and I see them, but I have a little satchel with me, kind of like the little box I brought in here tonight for our Cracker Jacks. And I said, we didn't get 8 done. And they're, oh, see, we told you. Just, you know, you're way too ahead of yourself. Just let it go. Ease up. We told you, switch to decaf. You're too high charged. I said, well, no, actually, we got 15 done, not 8. And I recommend that you guys start drinking high test, because you can get a whole lot more done if you thought more creatively. The budget doubled and doubled again the next year. So I'm a fan of lettuce and coffee, and you can get a lot done if you show people a better way. With respect. All right, so one of the ways that you can really entice people to the ocean is with maritime history and shipwrecks. You could be in Oklahoma, or you could be on the coast. Doesn't matter where you are. It's exciting. It's a bit of swashbuckling adventure, exploring and discovering under the sea. And I have to say, one of the most exciting times in my life, in addition to marrying my wife, was being able to dive and explore the Titanic. And it's an amazing sight. And it's a solemn sight, but some of this imagery, this is the superstructure just beyond the bridge and where the captain's quarters was, but some of it is remarkably sobering, because there were 1,522 people who lost their lives there. It's very analogous to the number of lives lost in the World Trade Centers, and it was as solemn a sight or solemn an event at that time as the Trade Centers are to us in our time. But these images we brought to a court to explain what the site looks like. In the front end of this, the Congress declared the Titanic Memorial, the bow and the stern, leave them alone. But when we looked around and we saw all the material that was in what is called the debris field, where the bits, the parts, and the pieces of the ship that broke away would be found, we saw amazing distributions of pairs of shoes. Now, you're in Civil War territory out here, and you've probably seen Matthew Brady's photographs of the war victims. And you just imagine here putting what position, maybe a knee arched to the left and up, the other leg straight. And you look here, somebody who is probably tucked in a fetal position. All that's left of the human form, the demised human form, is the tanned leather, the shoes that are there. And there was a field, just no matter where you look, you would be finding shoes. So we shared that with the court, and the court realized that the debris field has to be part of the memorial as well. So that was one of the small gains in the expedition we led, but the expedition was the point of being able to explain to the Congress why the treaty that we had developed with other nations to protect the Titanic was worthy of approval. And that treaty was approved. We didn't join the law of the sea, but we did approve this treaty to protect the Titanic. And another one, which was a fun project, was raising the turret from the USS Monitor. I know there's a lot of heritage here from both sides of the Civil War, so I'm not going to go down that road, but I'll tell you, it was an exciting project working on with the United States Navy raising that turret, which is on display. If you're ever anywhere near Newport News, the Maritime Museum in Newport News is the home and the host for the preservation and the display of all the artifacts from the Monitor. So what I'll leave you with is my hopeful turnabout towards some notes of optimism, which is that the ocean is a marvelous place. Whether you choose to recreate there or you enjoy that every other breath that you take that comes from the ocean's generated oxygen. And as we look at this is a place in the Pacific, in Fiji. Coral there is rather healthy and pristine. They have periodic interruptions with both storms, tropical cyclones, but also some ocean heat waves that come through and can kill some of the coral, but it is growing back. But most of the Caribbean isn't. The Caribbean is in very, very bad condition. The Florida Keys has 98 to 99% of the coral dead compared to what it looked like 35 years ago. So it's happening around us, and it's happening in our area quickly, and we need to be ocean-minded for that. And the reasons are many. I hope I have explained a few of them to you here tonight. It's exciting, it's adventurous, but it's very serious business to be thinking about what is the ocean for us, what is it doing with us, to us. So you start with that adventurous black and white photograph, but then you come back to something like this in livid color to make us realize that it's a vibrant place and it has a role in our lives. But most important to me is that my granddaughter knows what I do somewhat. She's 9. And what I don't want her to do when she's sitting in an auditorium years from now listening to someone else speak, ask the question, why didn't the old man try harder? Because look what I've got. And I don't want her to live in a Mad Max movie set. She and I both thank you very much. And you're welcome to a Cracker Jack.
What is the law about changing the Gulf of Mexico to Gulf of America? I mean, how can that stand?
Actually, the right of the president to pick a name is part of historically existing. I'm not talking going back to the War of 1812 or 1776, but the U.S. Geological Survey is the agency responsible for naming geological places. The U.S. Geological Survey works for the President of the United States. The naming conventions allow a name to be changed, particularly, and here's the catch, particularly if it's U.S. territory. The U.S. is empowered to name any U.S. feature, whether it's Mount McKinley, Mount Rushmore, anything else. Mount Mitchell in North Carolina, my first ship, the Mount Mitchell. So the lawfulness of that act, it is not questionable. The president can decree that. Internationally, that's an international body of water, and we are not the only nation that borders it. So by international convention, there is an international body that adjudicates name choices. And this idea has not been brought to the international body at this point in time. So we'll pretty much be like China, belligerently calling it one thing while the rest of the world calls it something else.
The manganese nodules that are producing oxygen, do we know if that oxygen is coming from CO2 or H2O? If it's coming from H2O, not only are we getting oxygen, we're getting hydrogen, which could be used as fuel.
The Porsche Motor Company is looking at that very transaction, but not, good choice if you're driving one, but not from the knowledge of the manganese equation, right? There is a genesis of fuel using water and carbon dioxide and trying to make burnable fuel from that, trapping the hydroxide, or excuse me, trapping the hydrogen along with the carbon. We don't know how, what's called dark oxygen now. It's dark oxygen because we don't shine any light on how it's happening. So it was only recently discovered by a Scottish team that made their way out there and was doing this work, in part funded by the Metals Company, which is a commercial outfit that's trying to harvest these manganese nodules and other components of seabed minerals, including grinding up extinct or terminated hydrothermal vents, which are mineral rich. Those vents are all minerals. But the question of what is the environmental consequence of the grinding, there are many open questions right now, but the one that compels me the most is, that's a pretty cool science question as to how we're producing oxygen down there, and we don't know. That's why they're continuing the study. But the other component there is, when we do find out what it is it scalable, and can we find a solution? But we have to ask the question, so thank you for that question. Wish we knew.
Could you go over what the Cracker Jacks mean to you again? Did a prize tell you that the ocean was going to be 4 feet? A little prize told you that?
The little riddle. When in
Oh,
the old
okay.
days of Cracker Jacks, you maybe get a pinky ring,
Right.
and then a riddle.
A riddle.
Or a
I'm-
joke. It was the riddle.
Okay,
It was
got
the
it.
riddle. I'm giving away my age.
Thank you, Craig. Very interesting discussion. Is research under threat? And if it is, both climatic and oceanographic research?
I think more climate research than ocean research. The Trump administration did issue a presidential memorandum instructing all federal agencies to go and map the U.S. exclusive economic zone. That U.S. EEZ is only about 30% mapped right now. The world ocean is about 26% mapped, excluding each nation's exclusive economic zone. Some countries don't share that. We share that willingly. The United Kingdom, many other countries share that willingly, but countries like India and a few others, certainly China, where they have more military concerns, they don't share their exclusive economic zone mapping, which makes it very difficult to do global mapping because you have these large voids. Our climate research is in worse expectation, in my view, than ocean research. The ocean research can translate readily into economic gain. So too should climate research translate into economic gain. But denying climate as the presidential platform is going to be very problematic to sustain all of the climate work that we have. Now, during Trump 1, 8 years ago, the political appointees came to me and told me that I had to stop doing what I was doing, because I was responsible for the climate program, among others, and that we needed to start bringing in other voices. Well, what is that code for? Well, that's code for people, instead of your usual cast of characters. Well, we don't have a usual cast of characters. We survey the entire academic community, and we take the best qualified people with records of scientific achievement and publication. They come in and they review these proposals. So anyway, we go down this dance a long time, and finally, I asked our general counsel to produce for me a memorandum that pointed out what was I required under law to do. Because one of the other things they said was, well, then just put the information out there. Don't try and explain it. Just leave your explanations out of it. Well, the law requires us to do that with the best informed scientific minds, to make the measurements, describe what's happening, describe why it's happening, and tell the public what it looks like things will be in the future because that is happening. So there it was, cradle to grave, the whole thing. And when I presented that to them, I'll leave for another opportunity exactly what happened to me after that, but it wasn't pleasant, but it prevailed. I worry about that this time because the state of the law seems to be less consequential to the moves that, what are we in now? Not even a week, that the administration is making in order to bring into focus the idea of how much authority does the president have, as opposed to the more traditional balance that we have been accustomed to between the legislative branch and the executive branch. So because climate is denied, I fear for the climate program. The same tactics repeated, I would have been gone in a heartbeat. I just don't think they were on their game because they could have gotten rid of me, but they didn't. So it's going to be a real challenge. I wish I could be more optimistic on that.
Quick question.
Yes.
Craig, thank you so much for sharing your knowledge and insights with us. We learned so much. Do you favor one weather model over the others? we hear about the European model and different models, you know, when we hear the weather forecast?
So, thank you very much for that question. So, when you're getting too far over your skis, you could punt, but I'm not going to punt. I've asked that question many times. The people who I was responsible for developed the new finite volume cubed model, which you probably have not heard of, but it's the world's best climate model. And they are downscaling it to also include weather. So we started with weather models and then extended out towards climate timescales. They built a whole new model with a new methodology and architecture, and it proved to be the best. Even the Europeans, which are very competitive, and at times their weather model is better than our US weather model. But the Europeans came back and told me, you've got the best, not me, but the United States has the best climate model. Oh, thank you. They prevail. The European Center model prevails often, but I ask the people who know really what they're doing, the weather forecasters, the National Weather Service forecasters, what models do you use? And each of them, when I ask that question, they look and they half smile, some of them chuckle, and they say, we use them all. Some models behave better in certain circumstances, and we know to rely maybe another extra 10% on that model, and others not. No one single model is doing it all with superb excellence. So the forecasters, and this is where they really, my heart goes to those forecasters. If you see an event where someone has lost a life, please know that somebody goes home that night asking themselves, could I have done better, and warned those people? And that's what your National Weather Service forecaster goes home with if there's a tornado or a hurricane or any other event that's weather generated. They care. And because they care so much, they're not wedded to their own company's model, if you will. But if I may, the note on privatizing weather forecasts, where do you think the Weather Channel, where do you think AccuWeather, where do you think Channel 6, Dr. Bob or Dr. Jane gets their products from? They get it from the National Weather Service. They get the analysis of the forecast of weather coming from the National Weather Service. So we need those folks. Every model, they look at it in a compendium, and they make a choice thereafter. There are strengths to the European model, clearly, particularly on the weather side. The other point I'll answer in distinction is the European model takes longer to run. It's a fatter model. It's a bigger model. Therefore, it's not illogical to assume that it could have a higher degree of precision because it's taking longer to generate. We put ours out every 4 hours. Our American commerce, our American transactions of people and the things that we do, we can't wait for longer than 4 hours. That's time difficult. So we have to have a model that is conveniently fitting within that size and time envelope. Use them all.
So I was seeing the charts that say the sea level is rising. So two-part question. Does that mean that West Virginia is getting shorter since we measure elevation from sea level? And two, how is it that sea level rises differently in different places around the globe?
So first let me say that the esteemed dignity of the state of West Virginia will not suffer by the rise of sea level. We will still continue to hold this state with such high esteem and regard. Sea level being the platform of elevation rise is part of the whole geodetic survey equation. And right now the rate of change is so low that you're not changing how many feet of elevation is the principal prominence in your state. But that change is forecast to happen much more quickly in the next decade plus. So we will start to see what might be a 1 foot less elevation based on where sea level is. But right now, we're still in the small tenths of a foot. Now, sea level is rising different ways, different places. Some of it is in, and this is going to made my head hurt first time I heard this, but this is going to stretch you a little bit. Warmer water has greater volume than colder water. So as the warm water extends to many other places around the globe, there's more water on the surface area intersects with the shoreline, sea level rises. So increased temperature is rising the sea level. There's something I didn't mention, and we have to be honest with ourselves. Go back to my Jack Kennedy example. We have to look at all the attributes. We also have subsidence. And the amount of subsidence that we have is measured by geologists who are looking, and geodesists as well, who are looking at the elevation of the Earth. But we have parts of the United States alone that are actually sinking. It's not just because of oil extraction in certain areas where you're getting compression out in the middle of the country and the level of the earth is shrinking because we've taken fluids and volume out of there. But because way back, the asteroid that whacked the planet Earth and knocked out the dinosaurs, the Earth is still rebounding from that resonance. And as that happens, it's a jelly-filled heat cauldron in the center of the Earth. It's not finite and solid. So there is flexibility in the surface of the Earth. So what we're experiencing in, for example, closest to here, Norfolk area, any Navy veterans in here that might have been in Norfolk? So the Naval Operations Base in Norfolk, it floods on sunny days, not storm, and not full moon either. It's because of the wall of water that might be coming up. I'm not talking about a tsunami, but just a tidal flow and subsidence of that landmass. Other parts are not subsiding, and they're still seeing sea level rise. So the net subsidence is less than the net increase in sea level rise. It happens different places because of the ocean circulation, more warm water coming in. Winds are changing based on prevailing wind patterns as the Arctic breaks up. The complication of this is not insignificant, but it results in a higher expectation in the Gulf of Mexico for sea level rise than on the Atlantic coast, and lesser in, for example, the Pacific coast. But it's rising everywhere and all around the world. Thank you for the question.
I think we can take one more.
Two-part. Is there a specific area, like 100 feet off the coast, that is all part of our ocean, that book that belongs to us, or I don't know if that's right where it belongs to us, but is there X amount of feet off the coast?
Yes, yes. It's in levels and layers of jurisdiction. The farther you get from land, the less property ownership I have of what's on, in, and under the water. Okay. But the states own either 3 or 9 miles. Texas, parts of Florida, they have a wider state ownership of land. The federal waters start at either 3 or those levels and go out to 200. In that 200, we have the right to the mineral resources, the animal resources, fishery resources, et cetera. That's ours. A ship of another country can transit that exclusive economic zone. They can't come into the interior waters, which would be the 3 miles in. So innocent passage is the term of art that's used in the law, so that if a vessel is going from point A to B and it has to skim through your exclusive economic zone, you can transit, but you can't stop and do anything. Can't fish, can't mine, you have to keep transiting. So the closer to land, the more absolute the ownership of that land mass is, not just for the United States, but for everybody. And the farther you get, the more attenuated those rights are, until you get to the blue water, the open ocean, where you have to look for a convention to try and protect that and have everyone agree on that convention.
That was my second part of the question. So in simplified terms, we have a giant easeway or passway that nobody really owns. And so anybody and their brother can go in there and start looking for minerals and looking for whatever it is that they think the ocean might then have.
Yeah,
and disrupt our whole process.
You're right. I think the only exception to that is under the Law of the Sea Treaty for marine minerals, for harvesting marine minerals. These are largely available in areas that are part of a nation's exclusive economic zone, for which that nation should have every right to do whatever they want to do. Some of them are selling their rights to other countries who are speculating on the opportunity to go and pick up these nodules. But the other part is that because of the location of some of the concentrated mineral resources, the international body, the Law of the Sea Treaty participants, have said we need to protect that part. They weren't willing to protect the biodiversity just yet. That has just come of late. But we're willing to protect those mineral resources more for the purpose of profit sharing rather than conservation. So the profit sharing idea is what Reagan originally didn't like in the Law of the Sea Treaty, because it was, if you take the risk, you should get all the reward. But the idea within the UN was, we have some impoverished nations that have no access to ocean, or they don't have the equipment to go. They should get some small percentage. The percentage originally negotiated was a little too high. Reagan said no. It was renegotiated. and to the point of his satisfaction, and then Reagan said, okay, yes, this is good. But somehow or another in the U.S. Senate, that Law of the Sea Treaty has stayed as a don't touch it. It's leave it alone.
Greg, if I could build very quickly, would you mention the Arctic, how the Arctic comes into play now, the melting of the Arctic with the law of the sea and the question the gentleman asked?
Thank you, thank you. So as the Arctic becomes ice-free, it's much more accessible. There are international agreements between countries, but not a unified treaty to leave the Arctic alone while it's melting. But people are ready to go up there and fish. They're also ready to go up there and harvest minerals. And the Arctic got carved up to a certain extent by an article in the law of the, any students of the Law of the Sea Treaty in here? Okay, because you wanted to know, it's Article 76. You can go look it up. But that article defines how a country can extend its continental shelf. And it's a geological formula. If the slope of the land equals this, and the measurements of the penetration of sediment, it's geologically complicated. But you can extend your continental shelf out beyond the exclusive economic zone. And in so doing, we've carved up between Russia, Canada, the United States, Norway, we've basically carved up most of the Arctic, but there are still some donut holes in there, if you will, that are not under any nation's control. And there is the prospect of mining in those areas for minerals. Plus, we all know Greenland is a target. There are a lot of minerals in Greenland. The Chinese, I've been to Greenland the past 2 summers, and the planes are flooded with people from China who are looking with briefcases rather than backpacks. So they're looking to be developing industrial opportunities in parts of Greenland where the minerals are abounding. But in terms of the Arctic, it's another kind of cowboys and Indians out there, just as it is in that area we mentioned earlier, where it's not a nation's control, but it's under UN control, that Clarion-Clipperton Zone, which is adjacent to Hawaii. It's outside of our EEZ, but there are several pockets of these around the world. So talking about cowboys and Indians and no man's land, that's a lot of the ocean. You're trying to get the governance established, especially when you have breakaway nations that are mighty, large, powerful, and not choosing to pay attention to the international regime. All right, thank you very much.
Thank you, Craig. You are a wealth of knowledge. Please join us out for a reception, and we have some tasty treats. And you can continue asking him questions out there, and feel free to help yourself to a box of Cracker Jacks.